Well, good evening, everybody. Welcome to Ellensburg. Beautiful evening here. I appreciate you joining us. 61 people already, 41 people, 60, what? Huh? Yeah, let's talk about that in just a second. I'll be right back. Yes, sir, Bob. It's 5:49 p.m. local time here, Pacific time in Ellensburg, and we will begin our program at 6 p.m. So, early birds, I've got questions for you. Let me grab a drink quick. Our framing here. Pretty good. So, first off, an apology. Last night, when we started what did we talk about last? Yeah, last night when we talked about supercontinents, I think about 50 people were waiting on another stream for me to start over there. And that's because I was experimenting with setting up a scheduled YouTube live session. And I was on my laptop and I kind of got to a certain point where I thought I was doing it correctly, and then I kind of gave up because it got too complicated for me, and I thought I quit it and like deleted it, but I guess I didn't. So for those that were on the wrong stream last night, I hope that you figured it out and joined us last night, or at the very least watched a replay of supercontinents sometime earlier today maybe. But I think I have it figured out. So my first question for you in our few minutes before we begin tonight is, were you aware that I had something on YouTube? I forget when I did it, like a few hours ago. Were you aware of some sort of scheduled, like, Nick from home is going to be on at 6 p.m. There was a little snapshot photo basically, and there was just a little button to like set a reminder for yourself. And I think some people were like chatting. I glanced once, I saw some people chatting, like you could even leave comments hours before we started. And I'm seeing some yeses and some nos. So I'm not sure it matters whether you saw that or not. Hopefully you know how to find us and you get your notification, or you look at the clock, or I don't know how you get to us, by the way. Actually, would you mind? We've kind of done this in the past, but how are you finding me in the evenings? Are you manually going to my YouTube channel and seeing that I'm live? Are you getting some sort of notification and you like click on the notification or something, it like automatically takes you to YouTube and this channel? Other options. And then I guess, I'll let those come in here. Notification, you go direct, say, Joan, that's helpful, thank you. I know there's notifications set up, but I don't know if you, like I struggle trying to find this thing when I go on my laptop here. I'm in a kind of a behind the scenes YouTube studio, it's called, and I always have to remember how to do that and find it. Okay, well, they're going too fast for me, but thank you for that. I'll kind of read those comments. I always watch these programs and see all these comments afterwards, and that will help me. My next question is, for those that found the scheduled thing, I don't even know what to call it, but like It's a scheduled, Nick Zentner will be speaking tonight at 6 o'clock, and here's a little reminder, basically. Was that helpful or kind of silly? Doesn't really matter to me on my end. I was hoping it would just reach a few other folks who typically have a hard time finding us. But so if you were aware of the scheduled thing, what are your thoughts on that, and if I should continue with that or not? Up until this point, I haven't really done anything with YouTube. I just, manually punch stuff into my phone at 5:45 and then kind of hit the live button, and there we go. And I've been going to occasionally with Facebook and Instagram and Twitter, just occasionally saying, here's my schedule for the next couple nights, that sort of thing. Last question. I got a bunch of questions tonight. I got to start thinking about my topic. It's a challenging topic tonight, by the way. My last question involving this is, I have a YouTube feed. So in other words, the YouTube channels that I subscribe to, I go there multiple times a day, and I kind of see, okay, David Letterman and Norm Macdonald and Pardon My Take and all these things that interest me. And when they upload a new program, I'm not really talking about live now, I'm just talking about when they upload a program, it shows up on my feed kind of chronologically. These live streams, our live streams, this stuff right here, Nick from Home, it doesn't show up on my feed until the next day. And I'm curious if that's your situation as well. Like, let's say you missed the first half of last night and you caught the last 20 minutes or something, and then you're like, oh, I want to watch the first part of it. Can you go to your YouTube feed and is it right there immediately? Or is there a delay of an hour and YouTube does something with I don't know what? But for me, it's super bizarre because in my YouTube feed, it's truly at least 12 hours. And first couple of times that happened, I thought, oh God, okay, so the program's just gone, I guess. And I was all ticked off. And then it popped up, and there it was. I had to scroll back in my feed and saw the whatever, the petrified wood talk, and there it was. So I'm asking if you can watch these in replay form right away, or if there's some sort of delay, because there certainly is for me. And then finally, this scheduled thing that I put on, which I put on probably 6 hours ago, didn't show up on my YouTube feed at all, even though I think I subscribed to the Nick Zentner channel, and yet it didn't show up. So, as always, I wouldn't say frustrating, but there's always things to work on, and it's kind of fun to have this repetition and kind of work out these bugs. I'm not super savvy, but I usually can kind of figure things out, especially if I get a bunch of help. A bunch of people type in stuff, and I'm like, not helpful. But a lot of them are good ideas and good suggestions. Before I forget, as I usually do, we've got 3 minutes before we start. Here's the plan. I'm going to go more than just 3 days out or 4 days out. I think I'm going to get into this routine. We're going to be at this a while. We're going to be at this a while. So as long as we're at this a while, I'm going to keep rolling. So we're going to keep with our daily schedule. No live streams on Mondays and Fridays. That's been kind of the routine for a while. I've got some topics. Hope you can read them. So Tuesday, Wednesday, Thursday will be in Washington. But do you notice that I would like to try 10 o'clock in the morning next weekend? 6 p.m. the other times, but on the weekends I'm going to try, at least this next weekend, 10 in the morning. And that's primarily because I'm hearing from more and more people from overseas who would really like to join us live, and they're just not able to. It's 2 in the morning, it's 3 in the morning. They actually just changed their clocks this weekend, spring ahead or whatever. So I'd like to experiment with that, and if that ruins your routine, I'm sorry, but trying to please everybody, which may not be working, but I'm trying. I'll show you that again at the end, and then I'll probably post that around, but that's the plan. Oh, good Lord, we got 2 minutes. What are we talking about tonight? If you haven't yet, please report where you're watching from. I'm gonna have to look at my notes tonight. There's so much with this topic that I always have kind of a loose plan, but I can't be too loose or I'm gonna screw this one up. It's an exciting topic. I hope you enjoy it, especially if you haven't heard about this stuff at all. Baja, BC. All right, I'll collect my thoughts and we will begin. Hello from Ellensburg, Washington, USA. So glad that you're with us. My name is Nick Zentner. I teach geology at Central Washington University, which is like 5 blocks to the north. And this is my backyard, and I'm so glad that you're with us tonight. Tonight's topic is something that has been a controversy for 50 years. And it involves this mountain. Isn't this a beautiful... This is one of those photos that a friend of mine took, and then you hit some button on some program, some Mac thing or whatever, and it becomes even more beautiful than it was originally. But what I'm showing you here is a skyline and a mountain peak called Mount Stewart. And at the end of this talk, we're going to walk a half a block away, as we did last week, and I want to show you Mount Stewart. You can see this view and this mountain from our neighborhood. And yet, this mountain was the place that was first studied, and a paper was published in 1970 by Merle Beck, a geology professor at Western Washington University in Bellingham. And Merle may be watching tonight. He's on Facebook, and I saw that he shared this notice about this talk. So Merle, you're a hero to many of us. And Merle Beck, in the late 1960s, with some graduate students, studied the rock of Mount Stewart and published a paper saying that that rock was formed in Mexico, in Baja, Mexico, and then got moved almost 2,000 miles north using this new concept called plate tectonics to get it up here to northern Washington. Let me show you the kind of rock that Merle studied with his grad students in the late 60s. This is a rock. This is a rock hammer. All right, get my head out of the frame. Here's a hand. Focus on the hand. Focus on the hand. Focus on the rock. Please, I'm talking to the camera now. And that entire mountain range, that entire Stewart Range is granite. Now, granite in quotation marks, because technically it's a granodiorite. This is a granite that has a few too many black minerals But there's quartz in here, there's hornblende in here, there's biotite in here, there's feldspar in here, and there's a mineral called magnetite. And we'll come back to this in a bit and talk about what Murrow was able to measure in this granodiorite, but we'll just casually call it granite, okay? Granite, 93 million year old granite, quote unquote, of Mount Stewart and the Stewart Range. And this was the centerpiece of this crazy idea called Baja, BC. I don't know if you're part of the Short Attention Span Club, but let me show you right away what Baja, BC proposes, and then we'll take a step back, use the chalkboard, and kind of get our bearings, okay? I don't know, I think I just insulted you. I didn't mean to. So that granodiorite we were just looking at, that entire snowy range on the horizon, and the weather's been changing every few minutes here, so we may be taking a walk at the end of this and it'll be all socked in with clouds, but we'll give it the old college try. So what is Baja, BC, and how does it relate to exotic terranes? That's what we're going to start with on the chalkboard, kind of picking up where we left off last night with our discussion of supercontinents and Pangea, and the fact that Washington and Oregon were not here during Pangea time. But here is an excellent cartoon that still holds up from Darrell Cowan at the University of Washington. This is 1997. And so I want you to mainly notice the dates. These are dates in millions of years ago up on top. And what this orange thing here and some yellow is this block of crust, and this is the most simple view of it, the most cartoonish view. There's more complexities involved. Just lost the sun for a little while. Maybe it'll come back. But I basically want you to see that the proposal is a piece of Baja, Mexico is now mostly in British Columbia. Take a piece of Mexico and get it up to Canada. And you're like, that's impossible. That's a crazy idea. That's what everybody said, except Murrow and like 3 other people in 1970. Well, I'm sharing the idea with you because I'm into it. And more of us are into it because there's more and more field evidence now of different kinds that support Baja, BC. I'll tell you right up front, not everybody's still on the board. There's some holdouts that say this is baloney, but more and more geologists are believers, if you want to use that word with science. They feel good with the amount of evidence. I promise I won't pull this away from you again. So you can maybe see, let me zoom in close enough where you can see political boundaries, and you can see that we're moving this thing north gradually. And I'm sure you have basic questions. How is this possible? How long did it take? Well, here are our numbers we're going to use. We're going to do our movement of Mexican crust up to here between 85 and 60 million years ago. We know that the movement is done by 60 million years ago, and we know that that northern movement, that El Norte movement, didn't begin until about 85 million years ago. Did you catch the date of Mount Stewart granite, by the way? '93. So I did collect this personally from Mount Stewart. And this is 93 million year old granite from Mount Stewart. So I'm holding a piece of this orange thing. And I'm telling you that this granite, do you know how granite forms? Kids that are joining us, I'm glad you're with us. A granite forms when you have hot liquid magma underground, oftentimes underneath a volcano. It's a big underground room. It's dark, but it's hot magma. And that hot magma starts to cool off and cool off and cool off until you can touch it because it's not hot anymore. It's a solid rock. And if this is a 93 million year old granite, and it is, that means that this magma went from hot to cold 93 million years ago. In Mexico. Mexico. Can I hear maracas? Big guitars? Okay. So tonight's one of those nights that I'm particularly amped because it's a challenge for me to convey this in just a few short minutes. And it's a challenge for you. Just like last night was a challenge. I'm hiking up my pants now, my belt. Got some work to do. Because last night we were dealing with hundreds and hundreds of millions of years with 3 different supercontinents. In fact, let me go to that. So I didn't erase this last night, even though it was out in the rain this morning. It's still with us for the most part. This is a quick attempt from last night to take a body, a human, and stand him next to a geologic timescale and remind ourselves, ooh, the wind's picking up. Remind ourselves that most of Washington geology is quite young, above my belt in the Cenozoic. And we'll be, this coming week, with Tuesday, Wednesday, Thursday, we'll be back up here. At the chest, at the neck, at the chin, whatever. But tonight's topic, what were the dates? 85 to 60? 85 to 60? So we're down during the dinosaur time. We're down mostly in the Mesozoic. We're below the belt tonight. But we're not way down to the feet. That's where we were with supercontinents, especially the 2 older supercontinents, Columbia and then Rodinia. And then you might recall that Pangaea was here. So we're always trying to make sure we know where we are in this grand story. We're not quite as old as last night, but we're still pretty damn old. Okay, let's go to the chalkboard and do a couple things. Hope you're feeling good. Hope you can hear okay. The trains are going again tonight. Essential business, apparently. And let's do it. So last night, we didn't quite finish the story. Last night, we had a bunch of rocks. I did exactly this last night. Do you recall? What were those rocks? What kind of rocks? Quartzites, slates, argillites, metamorphic rocks. Originally, those deposits were beach rocks, we said. And this was the Belt supergroup. The Belt Mountains in Montana, indicating that we have this massive coastline during more than one supercontinent. So this was a long-lived west coast. And we quit last night, and we still had not built Washington. Although I did say that after Pangaea started to break apart, by the way, if Pangaea is starting to break apart, that's the most recent supercontinent. Remember? North America was connected to Europe and Africa during Pangaea. So if we start to break apart Pangaea, and we did 200 million years ago, North America starts to move west. And the Atlantic starts to open, and you can't see it, but off that way going into our bedroom is Europe and Africa. Okay? That's important. Because as we start to break apart Pangaea, 200 million years ago, this deep ocean has a floor. And in the most basic, mostly wrong message, but the message I've been giving my 101 students for 30 years, that's right, I've been teaching stuff that's mostly wrong. It was a teaching choice because there's so much going on with what we're about to do. But let me give you the mostly wrong, yet satisfying and simple message. Starting 200 million years ago, North America and John Stockton's house start to move west, and the ocean floor beneath the Pacific Ocean at this time starts to move east, an ocean plate called the Farallon Plate. And again, the mostly wrong and very simple message that I've been giving forever is that that moving ocean floor was like a conveyor belt, and the conveyor belt had big islands on it. Big pieces of land. And as you continue to move that Farallon ocean floor, and you subduct or dive, now are you with me in cross-section? The Farallon Plate is diving beneath Spokane. And as you subduct the Farallon Plate, mostly wrong, but stay with me, if you subduct the Farallon Plate, things that are riding on top of the Farallon Plate are going to be lifted off of the downgoing ocean floor and added on to the leading edge of the North American plate. And so to finish, the mostly basic, the mostly wrong story is that if you do 200 million years of that, if you do 200 million years of Farallon Plate subduction and 200 million years of taking these islands or pieces of other continents or pieces of the ocean floor themselves and you cram them onto the edge of North America, you build Washington, Oregon, California, Nevada, British Columbia, Alaska, piece by piece. Let me show you a very colorful, complicated map from Bob Hildebrand that will show you the complexity. The sun is dancing in and out. Clouds are coming. Let's see, how can I do this? This is a big piece of paper. Let me just give you a little feeling. So this is Alaska. The entire state of Alaska, every color is a different one of these pieces of land. An exotic terrain. A piece of land is exotic to North America, made elsewhere. This is going to be flapping, but let's do it anyway. Sorry, Bob, I'm going to fold your map. It hurts to do that. All right, Alaska, British Columbia. Every color is a different exotic terrain that now is making up a portion of that crust. And then look what happens when we get to Washington. We lose all the colors. Let's continue under the fold. There's more colors, there's more exotic terrains in California. There's more colors, there's more exotic terrains in Baja today and in mainland Mexico today. So all I'm trying to show you so far is that there's an incredible mosaic, an incredible quilt, a quilt of many colors. I've been listening to the old Dolly Parton podcast lately. She's on my mind, okay? So, those exotic terrains were definitely not made here. They came from somewhere. They're far traveled. Okay, let's get off the mostly wrong story. Again, that I've been doing forever. It turns out that we did not have a major Farallon plate coming at North America for 200 million years. That's the simplest way to present it. And in a Geology 101 classroom, who gets hurt if you say that? It's a simple concept and it works fine. But we're now doing Geology 201 or Geology 301, or hell, maybe this is Geology 401 tonight. And we need to come to terms with the fact that we don't have a simple Farallon plate coming at North America for 200 million years. Therefore, we have these exotic terrains that definitely came from somewhere, but they just didn't come from out west. They didn't come across the ocean, which is kind of the message that I would give. Instead, if you're a Baja, BC person, many of these terrains in Washington, British Columbia, and even a few in Alaska were in Mexico and got moved north thousands of miles between 85 and 60 million years. Now, I have to show you the evidence for that. But that's the adjustment we're making. The mostly wrong thing is saying all these terrains came in off the west. We're changing the tune now. I'm changing the tune and saying that many of these didn't come from the west, they came from the south. They crossed the border into the U.S., and many of them crossed another border and got up in British Columbia. And if you're feeling playful, in the last 10 years, some geologists have realized that a couple of exotic terrains in Washington came from the north. They were up in the Arctic. They were up in Scandinavia and Greenland and came down and arrived. So to do that, it's kind of a two-step process. First of all, you kind of make this interesting case, kind of like we did last night, where you've got stuff here in North America, and then you find a match with more bedrock that matches chemically and age-wise and everything else, isotopically, with another part of the world. And then the second phase is, how are you going to do that? How are you going to bring that stuff? You need a moving ocean plate. That's the common way that we view that. Okay, I hope I have you interested now. We almost have 400 people. I don't want to lose you. So I need to show you some evidence. That's crucial in all these talks, isn't it? You can have the most sexy stories you want, but you better have some good evidence to present. Otherwise, it's just your opinion. And you'll just like, well, that sounds like baloney, and I guess we'll just agree to disagree. It's not an opinion. You need basic facts, basic evidence, and then you build your stories around that evidence. All right, so how is it possible to move these things at all? Let's go right to Baja, BC. How is it possible? How is it physically possible to do what Darrell Cowan presented here? And it wasn't just Darrell, it was Merle originally, and then a bunch of other folks as well. The growing bandwagon of Baja, BC people. How is this even possible? Well, I'm indicating that you need a moving ocean plate offshore in the direction that you want to move these things. So obviously, if we're proposing, I'm saying we now. I'm not doing any of the research, but you know what? I'll just say we because I'm in this camp now firmly. If we're moving this stuff north between 85 and 60 million years, we need a moving plate moving to the north, an ocean plate offshore of North America. Do we even know if that happens? Well, yeah, that's happening today. Let me give you a pretty modern example. Can you think of where that would be? Of a mostly northern moving ocean plate taking a piece of the continental edge with it and moving a piece of a continent north up the margin. That's correct, DG Sam. That's correct, Lethal Lee Fox. So if you haven't heard this before, it's pretty cool. I get excited every time I present it. This is the state of California, expertly drawn. Here's San Francisco, here's Los Angeles. And many of you know that Eastern California has a huge mountain range. It's called the Sierra Nevada Mountains. You've heard of Yosemite National Park or Kings Canyon National Park or the John Muir Trail or the Gold Rush at the base, all that, right? And we'll call this granite as well. The Sierra Nevada batholith, which is just a huge batch of granite. So I've shown in red the granite. The original granite back during the age of the dinosaurs, and this granite, most agree, is the result of a subduction of an ocean plate for a while, and then you have a line of volcanoes, and then we're looking at the underground magma chamber. That's not what I'm talking about, though, tonight. What I'm talking about tonight is that pretty recently, up in my head, 20 million years ago and younger, and still going on right now. Do you know what I'm going to do? I'm not mad at you, I'm just rinsing this out. Starting 20 million years ago, a big old crack formed. It's the San Andreas Fault. You've heard of it. And for another day, we can talk about why the San Andreas Fault mysteriously showed up 20 million years ago. We have a good feeling for it, but let's not do that right now. And what am I going to do? Well, the San Andreas Fault exists because we have a mostly northern moving Pacific plate against a mostly southwestward moving North American plate. And each time we have an earthquake on the San Andreas Fault, a segment of the fault slips. And the Pacific plate side of the fault heads straight north, about 10 feet during a big earthquake. 10 feet of sudden motion with each earthquake for one segment of the San Andreas Fault. I'm not saying the whole fault makes an earthquake. I'm not saying this whole picture moves 10 feet. I'm saying technically each little segment, when there's a big earthquake, abruptly moves the fault, moves this part of the fault, this side of the fault lurches 10 feet north, not up, not down, not heaven, not hell. It moves north compared to the other side of the fault. And if you do thousands and thousands and thousands and thousands of earthquakes along the San Andreas Fault over the last 20 million years, you can do a lot of movement. You can move hundreds of miles. In fact, you can move, there's been a total of 200 miles of total offset of this portion of California compared to the rest. This part of California has moved 200 miles compared to the rest in the last 20 million years. What's the evidence? Well, that southern tip of the batholith is no longer there. It's been cut off cleanly. And where is that little red knob today? Banana slugs. Santa Cruz, Point Reyes, the Farallon Islands. This stuff used to be down here. It's been offset by 200 miles in the last 20 million years, 10 feet at a time, along each individual segment. I hope you see what I'm trying to do right now. I'm trying to give you a very recent example of how you can move pieces of crust north hundreds of miles if you have enough time and you have structures like this, a strike-slip fault or a transform plate boundary. And so when we look at Daryl's cartoon, yet again, we can see he's drawn the most simplest possible cartoon where he has a major San Andreas fault-like structure. But remember now, these dates are way too old for the San Andreas. Please don't get confused. These are much older dates, but we have a modern example, is what I'm saying, about a moving ocean plate. And I can't hold it. I got to say it right now. It was not the Pacific plate that was moving north during this time. It was the Kula plate, K-U-L-A. The Kula plate is gone today. Kula actually means all gone. But the Kula plate, and that's another topic for another day. Actually, our first live stream last Tuesday, it seems like 3 years ago, was over there. I'm pointing to where the stream was terrible in quality, but I got pretty advanced with that first live stream and talked about the Kula Farallon Ridge and the spreading ridge subducting beneath the Pacific Northwest. You can go back and look at it if you want, but I don't want to get into that again. But the point is, we had a Kula plate moving north up the coast, and we can picture, at least in our simplest version of our minds, strike-slip faults, making earthquakes 10 feet at a time if you want, but we can do a lot of movement. And yes, a few pieces of what were in Baja are now up in southeast Alaska. But easier to us to handle tonight, Mount Stewart in northern Washington. In fact, much of the North Cascades. So here's a very simple geologic map, an oversimplified geologic map of Washington. This is a bunch of the German chocolate cake. It's not brown, it's yellow now. So that's not going to help us because the exotic terranes are underneath that. This area is full of glacial till. That's what the gray is. That's in the way. We can't see the exotic terranes there. The Cascades are too young. So my point is, I'll show you this again in a second. My main point is, if you really want to look into Baja, BC and these exotic terrains and study the details, there's not many places to go to in the Pacific Northwest. Why? Because in most places, these terrains have been buried by younger things. Things that are happening in the chest and the head on the geologic time scale. The flood basalts bury so much. The Cascades bury so much. The glacial till of Puget Lowland buries so much. Oregon has more problems with volcanic deposits. So part of the reason we're struggling with some of the details is we're trying to read a newspaper and we can only see a few words here and there, a couple of little ads, and you're trying to tell the story, but you're blindfolded for most of the paper, if that analogy worked for you at all. So the North Cascades, the Okanagan Highlands, the San Juan Islands, the Rimrock area west of Yakima. Down in Oregon, there's just a few places like the Wallowa Mountains, the Greenhorn Mountains, the bottom of Hell's Canyon, the Klamaths. If you're familiar with those places, those are the places to go to study this Mesozoic or Age of the Dinosaur type stuff. In fact, you may be aware that only one dinosaur bone has been found in Washington. Only one. And for most of my teaching career, I would stand on the desk and I would say, there's not one dinosaur bone that's ever been found in Washington. And the students will go, no. They're digging up dinosaurs down. And I say, no, those are mammoths. That's Ice Age. You're wrong. Oh, no, John Day. I saw some like three-toed horse. Are horses dinosaurs? No. I'd get real pissed off, you know. Mock, but not really. Larry David style. And that first dinosaur bone, the left thigh bone of a T-Rex, was found on the San Juan Islands, on Susha Island. And the exotic terrain lecture that I put on YouTube that's an hour long with crappy video work starts with that as the hook. Like, did that dinosaur live in Mexico? Or did that dinosaur live in Washington? And you're like, what? Where'd they find the dinosaur? In San Juan Islands, on Susha Island in Washington. Well, then the dinosaur lived in Washington. Wrong! Because that material was part of this exotic terrain story and took this 2,000-mile journey. A dead dinosaur heading north. Good stuff. All right, 6:30 already. I got to give you some evidence. And that's what we'll do for another 10 minutes, and then we'll go to you. And we'll continue talking about evidence based on your questions. Yep. Okay. So, I'm going to give you a list, mainly so that I can remember my list. It's more than the granite of Mount Stewart that now is evidence for Baja, BC. We now have 4 different kinds of evidence, and it's a growing list, to support the original Baja, BC proposal by Merle Beck in 1970. Of course, we have to start with the granite of Mount Stewart, and his analysis. Merle's specialty was paleomagnetism. Not my strength, but I'll try to convey the basics of that with you. Since Merle's time, in the last 20 years or so, we have fossils that prove we have Mexican crust. I'll explain. We have bedrock matches. In other words, we have some bedrock that's way down south, and we have identical bedrock up here in Washington. Not a coincidence. And the newest, I seem to mention this word every night now, the newest is zircon analysis, just like we did last night with our Australian sand that was in Montana. We'll get into that as well. Obviously, I could do an hour with each of these, but I got to go quick because I want to stay on schedule and give you a chance to ask your questions. So let me try pretty quickly to help you see what Merle was able to measure in this granite, technically this granodiorite, in Mount Stewart in 1968. He was looking at one tiny mineral in here that you can barely see. It's called magnetite. Very difficult to see in a rock. But magnetite, as the name implies, is a grain of a mineral, and there's hundreds of them in a block this size. Those magnetite grains align themselves with the Earth's magnetic field. They're magnetic. a certain mineral that's actually magnetic and gets itself aligned to the Earth's magnetic field, which is invisible when that magma is hot and liquid. I got a couple cartoons. No props tonight because this is good stuff. I don't have to cheerlead too much. But I could have brought in the apple again. So here's a very basic cartoon of planet Earth and these invisible red lines, which are the magnetic field of our Earth. Our Earth is a giant magnet. And just like a bar magnet with iron filings you can use on your kitchen table, you can show the same kind of thing with the entire planet. Invisible lines that are all dictated by the outer core, the liquid outer core of planet Earth. What I want you to notice here, well, maybe you're confused. You probably are. What would you measure? Okay, you're going to look, Merle and his students are going to measure some magnetite grains inside of the Stuart granite, 93-million-year-old magnetite grains. I don't get it. How's that evidence that it used to be Mexico? Here's the idea. Let me zoom in. Can you see that these invisible magnetic field lines are intersecting the Earth's surface at different angles depending on the latitude? Let's say that again. Depending on where you are on planet Earth, you have these invisible magnetic field lines coming at you at different angles. The magnetic field lines at the poles are coming in almost vertically. But as you get away from the poles, the angle between the magnetic field line and your location is a smaller angle. And at the equator, essentially, the magnetic grains are horizontal. Can you kind of see that? Yes, there have been reversals in the magnetic field through time. Yes, the paleomagnetic people, like Merle, and now there's labs around the world, they take into account of all these polarities, they take into account the wander, they take into account all these things that you've heard about with magnetic fields. They're no dummies. They're some of the brightest people I know. They've taken into account of all of that, and yet they can still, with their calculations, measure the magnetic alignments in the Mount Stuart granite and conclude in their 1970 paper that Mount Stuart, which today is higher than 47 degrees north latitude, crystallized at 23 degrees north latitude, Mexico. So Merle and his students, and as you can imagine, he took a lot of heat with this. You know, we're just starting to learn about plate tectonics, and this guy's saying this massive mountain range got moved more than 1,000 miles, almost 2,000 miles, based on measurements of like this invisible magnetic field locked with these magnetite grains. It was just, many of the geologists didn't have the specialization even today to understand paleomagnetism, including moi. So you're like, okay, I guess I'll take your word for it. But so Merle not only worked with Mount Stuart granite, but then after publishing that paper, he started working with the granites, Sierra Nevadas, other plutons, other kinds of rocks that were all recording paleomagnetic information, measuring the angle of those grains and determining latitudes. The only problem with that, the main problem with paleomagnetic studies, is you can determine the latitude, but you don't know if you're north or south of the equator. 27 degrees north, 27 degrees south of the equator. All you have is that angle intersecting with the horizontal. But if you have other evidence, and we do, then you can eliminate which side of the equator you're on. Wind is really picking up. Hope the audio is doing okay. Give me a few more minutes, man. I'm rolling, and I want to make sure I get to this other stuff as quickly as possible. I'll do this one verbally. I was going to draw it all out, but I don't want to now. You know what ammonites are? I barely know what they are. I'm not a biology guy. Big spiral kind of, you might have to Google, get some images of ammonites. Kind of like nautilus kind of guys. Very unique fossils. And there are ammonites that have been found in Mesozoic rocks here in the Pacific Northwest in some terrain material. And those same exact looking and aged ammonites are down south of Ensenada, Mexico. Now with all this stuff, remember Alfred Wegener last night? He had these things that were on opposite sides of the Atlantic Ocean, and he said, these are pretty rare things, and we got some in Kentucky and some in Chad or Morocco. Is it a coincidence, or did they used to be together? This is kind of the same thing. Just if the only evidence you have for blocks of crust moving north from Mexico is some ammonites. Peter Ward did this from University of Washington. Ammonites up here, same ammonites in Ensenada, same ammonites. They used to be together. And then half of that crust got moved up here and some got left down there. Plant fossils. We're still with number 2. There's some work that's been done. Again, you got to be with the right age. You got to be in the terrain. You can't be too young. It's got nothing to do with our story. You can't be too old. That's last night in the supercontinent stuff. We have to be in that Mesozoic material. But if we're convinced we're in the right time window, can you study the shapes of the plant leaves, the fossilized plant leaves? And can you say something about latitude or local climate? You're like, that sounds shaky. Global climate changes and everything else. They know that. There's ways to work with shapes and tie it to latitude. Let's keep going. You can see how if all you have is one of these, it's shaky. But if you have a whole family of evidence all pointing to the same conclusion, then for many of us, the skepticism drops each time you add to the list. This is maybe my favorite. There's ways now to carefully get detailed chemistry, trace elements, isotopic signatures, ages, folds, everything within a certain section of bedrock. The Swakane biotite gneiss, right above Wenatchee, Washington, matches very well with some gneiss/schist. Kids, gneiss/schist in Southern California. Coincidence? Or did they used to be together? Did both of those metamorphic units be in Mexico? Half of it got sent to Southern California, half of it got all the way up here. Bijou's running around now. There's more bedrock matches. Should I get into it? I'll do one more. Where's this rock from again? Mount Stewart. Where's Mount Stewart again? I'll go show you in a few minutes. You know where there's more of this rock? It's 93 million years old. Granodiorite signature. Bunch of granite. Joshua Tree. Southern California. Coincidence? Or did they used to be together in Baja? Some got sent to Southern Cal, some got also sent up here. All along these transform plate boundaries. Finally, I will use the chalkboard for this last thing, and then I promise I'm done. Zircons are those tiny mineral grains about the size of a grain of kosher salt. How could the zircons help us here? It's not obvious, but there is a way to do it. In this case, the zircons, it's kind of like last night actually. We're going to look at zircons carried by rivers. That's our old coastline that I just erased. The one, Spokane, Salt Lake City, everything else. So we got terranes on this side, we got Old Craton over here. And let's get our block of crust in Southern California and Mexico here. Hopefully it's in your frame. And let's have some rivers. This is actually pretty cool. I hope you're still with us. Almost 400, good. 400 of you, nice. Let's have some rivers when our block is done in Mexico. And let's have the rivers erode some bedrock in North America proper and let's send those broken pieces in the form of sand down the river, and let's sprinkle a bunch of zircon sands on top of our Baja, BC block. In other words, our block of Mexican bedrock, and we're going to just decorate the top of it, like some little confetti or whatever those like colorful things are you put on top of cookies. What do you call those? Can't think of what they're called. Okay? Rivers from old North America with a specific chemistry. The zircons are coming from bedrock right here, and we're sending the zircons of the same chemistry here onto this block. Now, let's move our Baja, BC block almost 2,000 miles. Here it goes. When's it going to start moving? 85 million years ago, 70 million years ago, 60 million years ago, it's done. And those zircons went along for the ride. Are you still with me? This is famous at a place called the Nanaimo group. We're back to the San Juans with that dinosaur bone. And other units that are sitting on top of some exotic terrains that did the transport. Do you see what we're doing? Study the details of the chemistries of the zircons that took the ride. Look at the chemistry and the age of the zircons and say, where was the source? Where were the rivers that deposited those little sprinkles? More and more geologists who do the zircon work are convinced that it's these rivers way down here south in southern Arizona and northern BC, northern Baja, and there's still a few geologists who think that the rivers were south, but they weren't that far south. They're coming from central Idaho and the Lemhi Range. My main hope, I hope you're not snowed over now, my main hope, 400, my main hope is that you can see that Baja, BC, even if you've heard of it, is not just an idea anymore. And we have a good list now that will continue to grow. And it seems to me that more and more people will be embracing this idea that was started by Merle Beck in Bellingham, Washington in 1970. Time for some questions. Thank you for your attention. Uppercase, please, so I can easily see your questions. I slowed down my scroll. Thanks for the suggestion. I went in, it was on fast, so I scrolled it down, and I hope I can read things better. Let me get this window a little closer. We'll keep this up about 15 minutes or so, I'm thinking, and then we'll take a walk if you're in the mood. Is there an alternative explanation for the data that you presented? Yes. There are still some geologists who are anti-Baja BC, but they also agree there has to be some northern movement of Baja, of BC and northern Washington. So everybody agrees there's northern movement. It's a question of, are you going to move a block 500 miles or 2,000 miles? If you're a Baja BC person, you're truly saying Mexican crust is in British Columbia, you're saying 2,000 miles in that 85 to, in our 25 million year time frame. If you're, the alternative hypothesis is you're taking Northern California essentially and sending it into British Columbia. I won't say good question because they're all good questions. We all know that. Does BC stand for British Columbia? Yes. Would we be able to find more dinosaur bones in Washington if they weren't covered with German chocolate cake? Evelyn, I love you. Yes, think of that. There's maybe a dinosaur bone beneath my backyard. But we got to go through the German chocolate cake to do that. Hey, where are you? You want to join us? Oh, here you are. Did you want to say hi? Yeah. Yeah. Let's say hi. Are you a believer in Baja, BC? This is Bijou the cat. I'm sorry to waste your time, but he doesn't join us that much. Oh, yes. You see these guys? Yeah, okay. See you later. How are you handling field... is that granodiorite from Mexico to Mount Stewart the same material as the Squamish Chief Monolith, and Howe Sound Fjord north of Vancouver, BC. I don't know much about those granites in the Squamish area. I've heard they're amazing. I've never been there, I'm embarrassed to say. I think some of them are Cretaceous, meaning they are of this age, but I can't be sure. I'm hoping to spend some time with Jerome Lessman up in BC this summer, so I'm hoping to go there among other places. I guess I didn't solve my scrolling problem. What evidence did they use in the past for the original theory of creation of California, Oregon, Washington, etc.? Excellent question. I don't know. Like, exotic terranes is an idea that you can't have unless you have plate tectonics. So, I guess in the 1940s and 50s and 19-teens, if I think quickly back to those geologic maps, they're just describing rocks. They're not able to date them very well, get ages on them very well. So it was more of an inventory, I think, is the best way to answer that question. Those geologic reports from the mid-1800s to the mid-1900s are more of like, here's what we got: basalt here, and we got quartzite there, and we got some serpentinite over there, and there wasn't a whole lot of why. I've never thought of it that way. Thank you for the question. How are zircons dated? I don't know. If you go to Exotic Terranes of the Pacific Northwest lecture, I have some video clips of people in a zircon lab that can kind of show you some of that process, but it's not my specialization. What is? What is in the zircon that gives dates and locations? Same thing. There's whole zircon labs that are just amazing, and they're producing this high precision stuff. Sam Bowering's lab at MIT, for instance, Mike Eddy and some others who are doing some work. I don't know the nuts and bolts of what they're doing. Any chance the craton going north? Well, the craton, I don't mean to nitpick here, but the craton is the old part of North America. So I'm not saying the craton is doing the moving. I'm saying it's these exotic terranes that are moving after, more recently than 200 million years ago. But I hate it when people do that to me, so I'm sorry that I just did that to you. Actually, it's not, sorry. Did that help create the Yellowstone hotspot sequencing? The Yellowstone hotspot story, if you want to go far back in time like I do, back to 56 million years ago, we still have all of our Baja, BC stuff in place. So I think I set up that Tuesday night, I'll show you the schedule in a bit, but Tuesday night will be our Olympic Peninsula lecture, and all of our Baja, BC stuff has arrived before we start building the Olympic Peninsula, and that, you'll see, ties to the Yellowstone hotspot. Can you tell us that is true about the Farallon Plate? Oh, I didn't mention that part. Well, I kind of did. So I told you the mostly false story is the Farallon Plate was coming at North America for the last 200 million years, right? That's what I said, but I kept saying it's mostly wrong. Now that you can see a decent stream, as opposed to live stream number 1, Canada, USA, Mexico. I now really, for the first time, as I was putting this new lecture together that got canceled, I guess I'll try to do it in the fall for a live audience. For the first time, I saw what appears to be a real thing by reading a bunch of papers and emailing a bunch of people. "85 million years ago," there's a bunch of reasons for this, but I'll just give you the story. 85 million years ago, a spreading ridge out in the ocean floor was sending Kula Plate to the north and Farallon Plate to the south. Well, right off the bat, we don't have the Farallon Plate coming at us. The Farallon Plate's down in Mexico, and it's going towards the equator. But the idea is that North America is drifting to the southwest over this stationary hotspot. Muffler boy. So by 70 million years ago, that spreading ridge is now up here in the Bay Area. And by 55 million years ago, the spreading ridge, again, between the Kula and the Farallon, is up in the Pacific Northwest. And 40 million years ago, the Kula-Farallon spreading ridge is up off the coast of Ketchikan, Alaska. So it looks like this thing is moving north, but I would ask you to think of North America drifting to the southwest over the top of it. The point is, if we go far enough back in time, we have a major Kula plate heading north. That's the magic carpet ride for our Baja, BC block. But there is an end for the Baja, BC transport, because by the time we get to our, what was our ending date? 65. The Farallon is in the neighborhood coming at us as opposed to the Kula heading north. Hope that made sense. A few more. Is that Grano did it already? How many of the 4 categories of evidence did Beck have in 1970? Just number 1. He just had the granite, and he only had the granite in Mount Stewart. Again, over the 1970s, he and other students went to other batholiths to take more measurements. Sierras, they kept finding that stuff is from further south. Actually, with the Sierras, is that true? Maybe it's not. It's not, actually. But he found more rocks besides Mount Stewart in the granites that showed that magnetism further to the south. Is the East Pacific rise younger than the Baja BC movement? I just kind of did it right there. This is, well, this isn't the East Pacific rise, is it? The East Pacific rise is not younger than the Baja BC movement, but it wasn't in the neighborhood at the time, so it doesn't help us. What's the name of the science used to determine latitude by magnetic? Paleomagnetism, you know, I have to say it. If Merle's watching, he'll be mad right now. You know, I was taught by the older generation in the 1980s, and we read some papers on paleomagnetism, and the professors said, well, these are paleomagicians. New idea, using a technique nobody understood, paleomagicians. Any relationship with the Rocky Mountain Trench? Eric, I'm sorry, I don't know much about that Rocky Mountain Trench. It's a structural story that I think is more tied to the Laramide orogeny and the building of the Rocky Mountains. So that's younger than our Baja BC story. But beyond that, I don't know, I'm sorry. Are there other areas in North America that have exotic terrains? Yes. Besides the Alaska to Mexico thing on the west, this ties into our supercontinent discussion last night. Before Pangea, North America was moving east, and Europe and Africa were moving west. This is before 300 million years ago, and exotic terrains were being accreted on the eastern seaboard. So you can think of all 7 continents as having a craton, kind of an old central area, and then around, well, we can do it here. So if you think of this as a continent, I don't care what continent it is, Australia even. And then you have kind of a margin all around here of accreted scraps, including North America with scraps all around. I'm getting cold. Sun just went down. Is the Juan de Fuca plate a remnant of the Kula plate? No, it's a remnant of the Farallon plate. So the Farallon is a more recent story, and we'll talk about that with the Cascades. So the Farallon is a thing, and it is a major story with the Western North America. But my main message tonight is the Farallon is not the story with our Baja BC. And so to say the Farallon was simply diving beneath North America for 200 million years in a simple west to east manner is incorrect, even though I need to send a handwritten note to every student I've had since 1992. And and apologize. Is Silesia, we'll talk about Silesia next time. When would the Pacific Plate come onto your chalkboard? Yeah, that's right. So the answer is shortly after, 30 million years. I'm still a little fuzzy on how we get things turned around so that our Farallon is a major thing coming at us. Can you hear that? My mom's probably watching, so I'm not going to do what I did. I already sang that. Multiple requests. Are the rocks in Pinnacles National Park? Where is that? I don't know. I'm sorry. Is the Cocos Pate part of the Farallon? Yes. Remnant of the Farallon. Craters of the Moon. There it is. Okay. So I want to take a walk with you if you're still interested. It looks like the clouds are rolling in, so I don't think we'll have much of a view, but I promised it, so we're going to walk anyway. One more look at the granodiorite. If I was really committed, I'd lug this with us, but I don't want to. I would like to hold this right in front of Mount Stewart and say, this is in that. But I'm going to have my hands full on our little walk. I sure do appreciate you joining us tonight. Let me show you the schedule for next week. That has one little twist to it. So this is the plan. Tomorrow night, nothing. Friday night, nothing. That's our normal routine. I'd love to have you join us again. Tuesday, Wednesday, Thursday here in Washington, topics. And then, well, I guess Saturday and Sunday are Washington topics too. But please note there's a new time on the weekends. We'll see if we can catch some European viewers and some African viewers and others who are jonesing to join us live, but are looking for a better time of day. Okay, I did this last week. It kind of worked. We're doing a field trip. I might as well tell you, I ordered a selfie stick, and I'm not proud to say that. But a couple of you suggested that I get and make it work. So that's not here yet, but I'll try to make it a little bit more professional looking, and I'll practice with my selfie stick as I walk around the neighborhood, and I'll just get laughed at from house to house. Okay, I'm doing two things. I'm turning you and get up, and give me just a second. Shit, how do I get off of this? Hang on. You know what? Well, another experiment. Let's just see if we... I'm going to show you some flowers. We just pruned the roses back. See if we can find Mount Stewart. You know where we're going? We're going to Mexico. We're going to go take a look at Mexico. I've already ordered the stick, so please don't give me advice on what I should get. Oh boy, I think we got too many clouds, but we're going to try. Am I still broadcasting? Oh, it's still trying to use wire. Oh, we can kind of see it. Are you still there? I'm on data now. Is that true? Good, thank you. Well, this is my walking route. Try yelling at my phone. All right, let me get down on the railing here. Well, I'm going to try. Going to have to use your imagination, but that low dark ridge. Oh, you can't see? All right, hang on. I'm going to try to get to data. I just tried to refresh. I don't know if that's any better. This is almost pointless, but we're going to do it anyway. So you can see two things here. It's not going to work. So there's a low dark ridge. That's the end of the German chocolate cake. The edge, the true edge of the Columbia River basalts. Just above that low dark ridge are mostly clouds, but I think you can see just a little bit of the Stewart Range, especially off to the right. Can you see it? Can't see, can't see, can't see. Well, just in case you can hear me, no picture. Are you kidding me? All right. Audio only. Wow, no kidding. I don't know what to say then. Well, I'm going to sign off then. Take your finger off. Give me a break. Well, this is a radio program now. So you can hear me, and I'm just reading all your comments. Black screen. I don't get it. I'm going to try one more thing. Hang on. Hang on. I turned it off and I turned it back on. Any chance? Do you have audio and video? You have video also? It works. Well, that was an interesting trick. Well, it's almost pointless at this point, and we lost 125 people, and I understand why, but we'll try it one more time. Thank you for sticking with us. So in those far clouds, above the low dark ridge, is 93 million year old granite from Mexico. Seeing is believing. And in the foreground, that low dark ridge takes a dip to the right. That's the Green Canyon Notch, and that's where the ancient river carrying the Ellensburg blue agates came through and dropped them in the alluvial fan. If I had my selfie stick, this would be more professional, possibly. So anyway, the wind is strong. It doesn't feel like Mexico tonight, but it is Ellensburg, Washington, and it's home to us. So I'm going to keep this. I'm going to say thank you for joining us tonight. I appreciate you joining all of these. Nothing happening tomorrow night with us, but I'll see you back here on Tuesday night. Here's to your health. Here's to people's health all around the world as we do our best to make it through this together. Good night from Ellensburg, Washington. I love you.